Can you hear now? Can you hear my voice?
Yes, sir.
Yes, sir.
Okay. Right. Find the supremum of a and okay. Okay, now obviously this you want to find the supremum for this set X. Like that you may expect the interpose exam they will ask for find the for one of the set you want to find the supremum property supremum values and infimum values. Since this one is one of the values in this set, this one should be less than 2 by 3 because you have managed there, obviously it's possible, right? Now, therefore, it is upper bound, right, for this one, right? 2 by 3 is an upper bound. You know that 2 by 3 in upper bound of S, right? The set S. Therefore, 2 by 3 upper bound means by the completeness property, right? By the completeness property, it is your infimum, supremum values, right? Supremum values. The supremum values whether maybe equal to 2 by 3 or less than equal to 2 by 3, right? This is your upper bound, right? The least upper bound is one here, right? Less than 2 by 3, least upper bound, right? You know the completeness property saying that 2 by 3 is one of the upper bound. By completeness property saying that the supremum should be less than equal to this value. Maybe this one equal or less than. You know that this one, suppose this one 2 by 3, the supremum value should be less than equal 2 by 3. That means whether this one equal to 2 by 3 or less than 1. Okay, that's the thing you want to prove that. Yeah, our client is now this one, right? Then by the completeness property, right? Then by the completeness property, you want to study the completeness property.
So body is not clear, sir. So body is not clear, sir.
Okay, just wait. Okay. Now it is okay.
Yes, sir, not problem.
Yes, sir.
Okay. Then by the completeness property, right? Completeness property saying that it's upper bound, therefore supremum exit, right? Supremum S exit, right? And the supremum value, right? Supremum of S less than equal to 2 by 3, whether equal to 2 by 3 or not, right? You know that you have the sum. If this is probably you can work it. It is your supremum value. Suppose your supremum value is supremum S equal to L or something, then here you can find L minus epsilon value. In this interval, you can find some values as N naught. It is possible, no? We already studied, the least upper bound is there. Right? It's possible, no? Right? Now your claim is, right? Suppose that the supremum S less than 2 by 3 what happened, right? In this case, you want to show that contradiction, right? Because I already mentioned here your supremum value is 2 by 3. Therefore, less than case is not possible. Therefore, you want to show that for this case contradiction. Then you can say that supremum value is equal to 2 by 3. Here there are two possibilities there. Supremum is less than equal to 2 by 3 means whether less than 2 by 3 or equal to 2 by 3. Therefore, for supremum value is equal to 2 by 3 because the least upper bound, right? Okay. In that part, I mentioned this one, right? That part I mentioned this one. You know, it is your line. Then here you can find some supreme values. You want this one study. You the least upper bound, the greatest lower bound. It is infimum, it's a supremum, right? Suppose the supremum value should be L. Then you can find some elements L minus epsilon here. Then you can find some element X naught. These are you already studied, right? The condition of the cumulus property. Okay. Now you want to show that for that part it's cannot exact because that is possible. Your supreme value should be 2 by 3. Okay. If we do that part, let you can choose one of the epsilon value should be positive. Therefore here obviously 2 by 3 minus supreme of S obviously positive. No, 2 by 3 minus supreme of S obviously positive. Right. Okay, I will try it. Okay. Epsilon equal to 2 by 3, right? So, yeah, right? More than this, but okay. Let epsilon equal, right? 2 by 3 supreme of S. Is it okay? 2 by 3 supreme of S. Okay. Then you can find such a n naught values belong to natural number, right? Such that this 2 by 3 minus 1 over 10 to the power n naught, right? This one greater than supreme of S minus 2 by 3 plus supremum of S. Yeah. Right. Therefore, supremum of S. Then you can do some operations there. Suppose we can add some here supremum of S there. Therefore, 2 supremum of S. Then what is a sign for this one? Here this one is greater than. Therefore, 2 by 3, 1 minus 1 over 10 to the power n naught plus 2 by 3. So this one you can write supreme of S less than 1 by 3, 1 minus 1 over 10 to the power n naught plus 1 by 3. Okay, right. This type of question you can expect to enter course exam, right? Because you can take the past papers, right? Previous years past papers, this type of questions there. Now, now supremum is less than, you can simplify that one, right? You cut the two terms, they are the 1 by 3. Hereafter, you can adding 1 by 3, 1 by 3. You can check multiplying 1 by 3. Yes, wait.
Not sound, sir.
Okay. Now you can manipulate this one, right? Supremo S, Supremo S. Here you can inside taking 1 by 3. Therefore 2 by 3 minus 1 over 3 into 10 to the power n naught. So, okay, 3 over 10 to the power n naught. Now this one equal to, suppose 2 by 3, right? Suppose 2 by 3. Take 2 in the outside, then 1 minus is half also there. Take 20 to the power n naught. Obviously, this one less than 2 by 3. Is it okay? If you add something here, 10 to the power you add here, then this function, this value should be decreased. Therefore, here you put less than 10. Since this one decrease means altogether increase. Is it okay? Therefore, less than this value. Now, this one, okay, this one 2 by 3, 1 minus 1 over 10 to the power n plus 1. Since, right, since, but about this value, 2 by 3, 1 minus 1 over 10 n naught plus 1. You know, it is these values of the form, right? This value of the form in the set S naught. Therefore, in the set S, n belongs to natural number. No? Natural number means n naught natural number means n naught plus 1 also natural number. No? Therefore, this one belongs to S. Now you check here, supremum of S less than this one. It is possible. Now, supremum of S less than 2 by 3, 1 minus 1 over 10 to the power n plus 1. Okay. Is it possible? Is it possible? No. Why? It is the greatest upper bound. There is no upper bound rather than this one, supremum of S. Therefore, it is contradiction. Contradiction means, right? Contradiction means our claim is wrong. Supremum of S less than 2 by 3 is wrong. Right? Supremum less than 2 by 3 wrong. Therefore, our claim is wrong. Therefore, you can, from this one, you can take the value of supremum is equal to 2 by 3 because less than 2 by 3 is not possible because it is a contradiction exists. Therefore, less than 2 by 3 not possible. Therefore, supremum is equal to 2 by 3. Right? Now we found the values for the supremum of S. Hereafter, you want to find the values for infimum of S. Right? Like that, here for infimum values also, like that you want to do it. Right? Let's rewrite it, that part. Infimum values, right? You know, right? You know, since n greater than equal to 1, natural number for all, right? N belongs to natural number. Obviously, right? Obviously, n is positive, therefore 10 to the power n should be greater than equal to 10 to the power 1. Is it okay? For all n belongs to natural number. And what happened for this one? Minus 1 to the power 10 to the power n. Is it okay? For our purpose, we do this part, right? Okay, 10 to the power n is minus 1 to 1 over 10 to the power n greater than equal to minus 1 over 10 to the power 1. You add both sides 1. You add both sides 1. Multiply one of the positive number 2 by 3, 1 minus 1 over 10 to the power n greater than or equal 2 by 3, 1 over 1 to the power 10 to the power 1. So, okay. As I do some manipulation, right? Okay. Now, you know that, right? It is one of the values, right? It is one of the set values in this set S, right? This is one of the set values, right? This is one of the set values. Therefore, it is your least. It is the greatest upper bound. Sorry, the greatest lower bound. No, least upper bound. The greatest lower bound. Greatest lower bound. This is your greatest lower bound. But the comparator's property saying that this greatest lower bound should be your infimum value. It's okay. Right. In this case also possible for here whether this one supremum infimum equal to this value, it's all the values or less than 1. Check that one for that part. Thus 2 by 3, 1 minus 10 to the power 1 is the low bound, right? By completeness property, same idea. By completeness property, completeness property mentioned that for infimum, it is least upper bound, right? Least upper bound, greatest lower bound. Low bound here, greatest lower bound means infimum exit, least upper bound means supremum exit. By the completeness property saying that infimum of S exit, okay? Infimum of X exit. Infimum of X exit. Infimum of X exit. Right. Therefore, right, infimum of X exit. Now you know that. Now you know that this one of the element, no, 2 by 3, 1 minus 1 over 10 to the power 1 should be belong to S. This one also belong to S. This one also belong to S. But this one is a least. Like this one is a least. Sorry, this one is a the greatest low bound. Right, greatest low bound. Greatest low bound. Okay. Now you have infimum S to this value because there are some values, right? There are some values. There are some values. It is your infimum. S is your that values. These values. There are some values greater than that one. Right? There are some values greater than that one. Therefore, the infimum exit. So, okay, infimum exit. The infimum exit equal to this value. You can simplify this one. You get 3 over 5. Okay, 3 over 5. Very easy part, okay? 3 over 5. I move to the next question. Give this a very big part question, right? Okay. Next part. X was set 1 over n. N belongs to natural number. You want to find the supremum and infimum of the following, right? Right. You want to find the supremum, find the supremum and infimum. Find the right. Find the supremum and infimum of the following set. And infimum, right, of following sets. Right. Of following sets. Right. Yeah. Following sets. Right. Okay. Since obviously 1 over n should be less than or equal to 1. For all n belongs to natural number. Therefore, this 1 is the upper bound of S. Therefore, 1 is an upper bound of S. Of S. by completeness property, supreme of S exists, right? And we have supreme of S H less than equal 1 and 1 belong to S, right? Therefore, for here the each upper bound the supervisor should be 1. Since 1 over n obviously positive than 0 for all n belongs to natural number, therefore 0 is a lower bound of S, lower bound of S. 0 is a lower bound of S, right? 0 is a lower bound of S. Right? 0 is a lower bound of S. Therefore, 0 is a lower bound of S. Then which values? Then increment of x exit. Increment of x exit. Right. But usually this increment of x should be then equal to 0. Assume that increment of s greater than 0. Take epsilon equal increment of s greater than 0. Here is n1 belongs to natural number such that 1 over n1 you can assume is the argument property here to increment of s. From this one you can write increment of s greater than 1 over 2n1. Is possible? It's not possible because increment value is the least upper bound. Because 1 over 2n1 belong to s, therefore it's not possible. Therefore, contradiction. Therefore, this is not possible. This is not possible means only possible for the increment of s should be 0. Right. Going to the no. Okay. Right. Now that question, okay. Increment 0, okay. Increment equal to 0. Now you can move the problem sheet, right? You have the problem sheet under the first chapter in the LMS. You have the problem sheet question, right? I like to do that question now. And if supreme property, income property is enough, but I can do some more questions in tutorial class, okay? Tutorial class. But now you like to do the some question, right? Some question based on the tutorial, right? Problem sheet. Okay. You have the problem sheet. You have the problem sheet. I think you have the problem sheet, right? This problem sheet. There are some questions, right? First question: if a plus b equal to 0, then b equal to minus a. Let's do that part. Right. First part you can do that. First part you can do that. Right. A part. Suppose that a plus b equal to 0. Then you want to show that b equal to minus a. What we do? There are some ways, right? There are some ways doing this part. I will do like this. First of all, you know that axiom is important, right? You can use axiom here. Now you can add both sides minus a. It's okay. Right. Now you can use the associative property. And you will use this one. From this one, from this two positive 0 plus b, right? Inverse of a is minus a plus 0, right? Plus 0. You know, this one you can write minus 1 into a plus this one 0 into a or a dot 0. It's okay. 0 into a or a dot 0 equal to 0. No? Right. Is a is inverse, they are altogether element 0. 0 plus b here distributed below there minus 1 plus 0 together a. Okay, therefore this one equal to b equal to here minus 1 0 minus 1 into a. This is the question, right? It's okay. Yeah, b equal to minus a. You already proved this part. B equal to minus a. Because you know that minus 1 into a you can write minus a. This part minus 0, okay. Here you can use the d1. I think d1 d2, no? You can write something there, right? d1 d2 you can use it for this part. I think this d1, right? d1 because of d1. Associative because of a associative property a2, no? A2, right? By because now by by D1. Okay, adding both side minus A. Right. Then you get this value. Is it okay? Next question. Second part. Second part based on the minus into minus A equal to A. Right. Minus into minus equal to A. Agree to that part? Next question. Minus into minus A equal to A. Minus into minus A equal to A. Next question. Question number 2. B part. Minus into minus A equal to A. For this part, right, for this part, you have A plus minus A by the identity. You can mention A plus minus A 0. Right, for all A belong to R. Right. From this one, you can then what we do? Then what we do? Now, this means this one. It is obviously true because this means this one, right? From this one. You know this one. Minus A, you can write minus 1 into A. Is it okay? Therefore, A plus, here you can write A root 1. This one minus 1 into A equal to 0. In this question, you are applying this one. You are applying, don't show this one, you are applying this one. Right? You are applying A plus minus A should be 0. This is your applying. Therefore, you assume that A dot 1 minus 1 be 1, A equal to 0. Otherwise, you can use the distributive law. Distributive law is okay. A belong to R. From the A3, right? The identity element A3, is obviously true. I think from the A3 we can easily identify it. That's the A3. A3. It is your A4, right? From A4, you can write this part. Your A4, right? It is your A4. From this A4, right? From this A4, from this A4, what is possible? It is obviously from A4. This one implies A equal to minus A. Right? There are more steps. Right? There are more steps. There's no more steps. They have A equal to minus A. Right? This part is important. From you want to put this one, you can write this part first. A equal to minus A 0. But this one implies this one. C part. C part. A equal to minus into minus A, no? C part this one, no? Minus 1. C part minus 1 to 1 into A equal to minus A. For this part, add here A into minus 1 into A. Right? This one equal to, right? This one equal to this one equal to 1 into A minus 1 into A. It's okay. Right? 1 into A minus 1 into A. Right? From this one distribute block, you can use it. 1 plus minus 1 into A. This is D1. D1. But this identity 1 and minus 1, therefore 0 into A. Or you prove 0 into A, again 0. Right? 0 into A, again 0. Therefore, this one implies because 0 into A, 0. Therefore, you can write this one 0 means you can write this minus 1 into A can come here. Okay. This one equal to 0, no, therefore minus. Equal to 0 is minus A. Next question. Next question. You put here in this question you can put A equal to minus 1, you get last one. If the part you put A equal to minus 1, we get put here minus 1 into A is a minus 1. Here you can write minus into minus 1. Okay, 1. Yeah, for minus 1 into minus 1, 1. Minus 1 into minus 1, 1. Is it okay? Minus 1 into minus 1, 1. because you all know that minus into minus a becomes a no. Therefore, here minus into minus 1 should be 1. You put a as a 1 now. Then here a as a minus 1 to get minus 1 here, minus 1 here. Hereafter, using the b part, right? By b part. By using b part, you can get 1. Right? By using the b part, you can get 1. Okay. These are something, but we can do more things, right? And if there are some more questions there, I will upload this answer in the LMS next week. Okay, don't worry about this. One. The easy part, you can easily do it, right? Okay. Now we will stop here. So C, can we do that? Assuming that a dot 0 equal to 0, a part b part 0, a dot 0 to 0. Then a dot 0 equal to 0. Then how we come up with say a dot 1 minus 1? How can you come this of this part? How can how can you come to this part? Right. Okay, I will stop here and I will do the next class, right? Okay. See you show again. Bye. Close करना बड़ा. Okay. I just